In this video, we're going to introduce the first lesson of Unit 4. We're going to be talking about similarity in Unit 4, what it means for certain figures and ideas to be similar. And so we're going to start off with one of the key concepts, and that is the idea of proportions. And in order to understand what a proportion is, we need to understand what a ratio is. Okay, so some of this will be a little bit of a review from some previous math content, but please follow along. If at any point you need to have the video paused, just indicate that you want to pause the video. If you're watching this on your own, again, just pause the video at any time to get caught up. Okay, but here's what a ratio is. I'll give you a moment or two to copy this down. A comparison of two or more values using division. And so sometimes we just write it out in words, A to B, quantity A to quantity B, or sometimes we use this colon symbol. We would still read it A to B, or we can use a fraction to represent that with the division being the fraction there, A over B. All right, so what I want us to do is to write these ratios. If we write it as a fraction, or if I use the colon or the words, I still want to write my final answer in simplest terms. That means I always reduce my fraction by common factors. Even if I'm writing it this way, I want to reduce the numbers by a common factor. So we're going to start off with this. There are 310 sophomores, 298 juniors, and 302 seniors at some school. What is the ratio of sophomores to juniors? Okay, this would be the first number, the A, and this would be the second number, the B. And so we always want to write in order that it goes, left to right, top to bottom. So sophomores was 310. If I'm writing this as a fraction, it'll look like this, 310 over the number of seniors, 302. And I would want to reduce that. And the only common factor I can equally divide by is 2. And when I divide each of these by 2, it gives me 155 over 151. Now, we could also write any fraction as a decimal or a percentage, but for our purposes today, we're going to stick with writing them as fractions. Okay, so what I want you to do is take some time to do B and C on your own. Try those on your own. Pause the video, and then we'll check our answers. Okay, if you need more time, keep the video paused. Otherwise, these are the answers you should get. Okay, for part B, the ratio of juniors to seniors is just 149 over 151. But for part C, this is a little bit different ratio than you guys are used to writing. Remember we said a comparison of two or more values. Well, we've usually just been comparing two values. Okay, but we could write a ratio this way using the colons of 3 or 4 or even 5 different values, or however many we had total. Most of the time we're going to stick with just 3 or 4 though. But this is a ratio comparing sophomores to juniors to seniors. Okay, unsimplified, that would just be 310 to 298 to 302. And then I can divide all those numbers by a 2 to get this. So this would be my final ratio. And we're going to use those three-part ratios to do some problem solving in our next few examples. So in this first example, it says the ratio of the angles of a triangle. That's an important part of this question. The ratio of the angles of a triangle are 3 to 4 to 8. Now that, if we're talking about angles of a triangle, we need to remember some key ideas about that. But it asks, what is the measure of the largest angle? Okay, so is the triangle acute or right or obtuse? That is our next step after we answer the first question. So there's really two parts here. Okay, so when we write the ratio of the angles of the triangle as 3 to 4 to 8, what you're telling me is that my overall ratio of the exact angle measures would simplify down to this. So there's obviously no way that these angles could be 3 degrees, 4 degrees, and 8 degrees. Okay, we know that the angles of a triangle, angle sum is always 180 degrees. All right, so what that means is some values that are multiples of 3, 4, and 8 here would add up to 180. Well, what that means is I don't know the common factor that reduced down to this, so I can call that common factor x. And so instead of just 3 to 4 to 8, I'm going to rewrite it as 3x to 4x to 8x. And that way, if I think of that as the expression for the first angle measure, that is the expression for the second angle measure, and that is the expression for the third angle measure, I can add those expressions up, 3x plus 4x plus 8x, and set it equal to the total that I'm using for the problem. Well, this time the angles of a triangle add up to 180 degrees, so that's where I get my total. Well, then I can just combine like terms. 3 plus 4 is 7. 7 plus 8 is 15. So that gives me 15x equals 180. And I divide by 15 on both sides. And we get that x is 12. Now that doesn't answer my problem completely. What it does is it tells me the common factor that I can plug back in here to find the actual angle measures. Okay, so here if I do 3 times 12 for the smallest of the angle, I know that's the smallest because it's the smallest part of my ratio. 3 times 12 is 36 degrees. 4 times 12 for the 4x is 48 degrees. And 8 times 12 is 96 degrees. Okay? And if I check those, all three of those do add up to 180 degrees. Well, the question asked first, what is the measure of the largest angle? Well, that would be the 96 degrees. So that's my first answer. And because I've found all three, I can actually answer the second question. Is the triangle acute, right, or obtuse? This largest angle is 96 degrees, which is greater than 90. So this is an obtuse triangle. So I need both of those answers for this problem. Okay? And then these next few examples kind of work out the same way. I'm going to do just one more of these, then you can try another one on your own. We're going to do this next example. It says the ratio of the sides of a triangle. Now this is important this time because we're not using angles. But it's the same idea. The sides of a triangle have a ratio of 4 to 8 to 9. So if the perimeter is 126 feet, find the length of all three sides. So the perimeter is my total now, not 180 degrees, because these aren't angles, these are sides. But that means I can rewrite these as 4x, 8x, and 9x to make that equation. 4x plus 8x plus 9x equals my total perimeter of 126, where this 4x is the expression for one side, 8x is another side, 9x is another side. So we're going to combine like terms again. 4 plus 8 is 12. 12 plus 9 is 21. So 21 equals 126. And we divide by 21 on both sides. That common factor for 4, 8, and 9 in my ratio, x, is 6. So each of the sides, if I do that, 4 times 6 gives me 24. And this would be in feet, so I do want to put a unit of measure. And then 8 times 6 gives me 48 feet for that side. And 9 times 6 gives me 54 feet for that side. So there's the lengths of all three sides. Okay? And that's how we can use a 3-part ratio, or maybe even a 4-part ratio. Okay? We could do the sides of a trapezoid. We could even do a 5-part ratio and do the sides of some pentagon and use a perimeter. So we're not limited to a 3-part ratio when we're doing perimeter. If we're doing angle measures, we just have to remember what those angle measures add up to from our previous unit. Okay, so we're going to skip this example for right now. Let's talk about what a proportion is. Okay, a proportion is simply an equation where we have two equal ratios. All right, so like A over B equals C over D. And then we have a property of this proportions that is going to help us solve these. In any proportion, cross products are equal. That means we can cross multiply to set the cross products equal. So if that's my proportion, if I said this, that means that A times D has to equal B times C. And it really doesn't matter which cross product we put on the left or the right of that equation, but usually we write it like that. Okay, so we can use that idea to solve proportions. And you guys have probably heard this done before or done some of these problems before in other math classes. So to take this example here, 4 over 11 equals x over 77. Now, there are definitely ways that you could solve this problem without knowing this, but in order to get to problems like these, I want to practice using our cross products. So we cross multiply. The word product means multiply. So I'm going to do 11 times x on the left equals 4 times 77, which is 308. Okay, 4 times 77 is 308. X times 11 is 11x. Then we just divide by 11 to solve for x. So x must have been 28. Okay? Same idea over here, part B. We cross multiply. I usually just put my x variable term on the left, so x times 5 goes first, that's 5x, equals 2 times 23, which is 46. And you'll notice this time we actually get a decimal. That's okay. On some of these problems with proportions, we will get decimals. So when I divide 46 by 5, I get x is 9.2. It's exactly 9.2. It's not this weird decimal that goes on forever. It just is a nice, neat 9.2. But here's where it gets a little more tricky. When we cross multiply this time, my expression here, x plus 4, I have to think of as a value altogether. All of that value has to get multiplied by 2. So you're really doing 2 parentheses x plus 4 equals 3 times 15. Okay, this is the step we weren't showing in these other ones. We were just doing the multiplication and writing it down. Well, now I want you to write this step out to make sure we distribute this 2 to both parts of that expression. So it makes it 2x plus 8 equals 45. 3 times 15 is 45. And now we can solve for x by just subtracting 8. So 2x equals, that's my equal sign, 2x equals 37, and divide by 2, and we get 18.5. Okay? So be careful to make sure you do both of those. Okay? We distribute on this side and we multiply on the other side. So let's try another one or two together. When we cross multiply here, there's an x in both parts of my proportion. That's okay. Let's just do it one step at a time. I'll go bottom left to top right on the left side. So 6 times x minus 5 equals 2x times 2. Well, 2x times 2 on that side can be simplified to 4x. And then when I distribute on this side, I get 6x minus 30. Well, now we need to get x by itself. This is a problem that ends up giving you guys some trouble, but it doesn't have to if you realize since there's an x on both sides but only a constant on the left, I'm going to leave the negative 30 alone. I don't want to add 30 to both sides. That adds an extra step. I'm going to subtract the 6x this time from both sides. That leaves me negative 30 equals negative 2x, but then we just have to divide by negative 2, and x is positive 15. Okay? I want you to pause the video here. I want you to try and do part E on your own, and then when you're ready to click play, you will see what the answer should be. All right, if you need more time, again, keep the video paused. Otherwise, this is the answer for part E. Okay, when we cross multiply, we get 3 times x minus 2 and 4 times x plus 3. Make sure you write the parentheses so you remember to distribute. And then when I solve, I get x is negative 18. All right, this is going to bring us to our final example for this lesson. Okay, it's another word problem, but we're going to use proportions to solve this. So we have to not only solve a proportion, we're going to have to use the word problem to help set up a proportion. So you're baking a cake that calls for 5 cups of flour, but you only have 3 cups. If you decide to scale back the recipe, to only use the flour that you have, to change the amount of flour needed, how much sugar would you use if you originally called for 2.5 cups of sugar? So what we're going to do is we're going to set this up as 2 equal ratios. We've got a ratio for flour, and then we're using a ratio for sugar, where I'm looking for my new amount of sugar in the measurement cups. Okay, so what I'm going to do is I'm going to set up an equal ratio. All right, so we're baking cake. Calls for 5 cups of flour. That's what the recipe calls for, but I only have 3. Well, one of these fractions is going to be the comparison of those two numbers, and you get to decide whether you want it to be 5 over 3 or 3 over 5. It's really up to you. I'm going to choose 5 over 3. So that means that 5 is what the recipe originally calls for. That's the top portion, compared to the bottom portion of what I actually have. Well, that's ratio is my flour ratio. That should be equivalent to my sugar ratio. Okay, even though they're different amounts, the ratio of scaling back my recipe needs to be the same. So if I decide to scale back the recipe and change the amount of flour, how much sugar am I going to use if the original called for 2.5 cups? Well, the 2.5 cups is the original. It goes in the same place as the original 5 cups of flour up top. That means my X goes on the bottom. This is one possible way to set it up. Another possible way, we could flip it this way. Okay, the 2.5 over X equals 5 over 3. You could flip it vertically. 3 over 5 equals X over 2.5. But either way, no matter how you set it up, if you do it correctly, the cross product should still be the same equation. We should still end up with 5X equals 7.5. Divide by 5 then. And the amount of sugar we're going to use now is only 1.5 cups instead of 2.5. Okay? And that's an example of how we can use proportions to solve some problems.